All right, we're going to do a little video here on finding horizontal and vertical asymptotes. Okay, horizontal and vertical asymptotes. All right, so as an example, you're going to have a function that can be graphed here. Start with a simple one. Something like this. We want to know what are the horizontal and vertical asymptotes. I will start with the vertical asymptote, which is very easy to find. All you have to do is set the denominator equal to 0. So as long as you're able to solve an equation, whether it be linear or quadratic, you're in pretty good shape here. So x minus 4 is equal to 0. The top would be irrelevant. We'll just look at the bottom, set it equals 0. So this one's very easy to solve. X equals 4. And as you'll see later when we graph, you do want to put x equals 4, not just 4. Okay, because I'll just tell you briefly here, vertical asymptote is a vertical line. If you remember from when you graph lines, you have to have x equals for a vertical line. Now the horizontal asymptote is a little harder or easier depending on how well you know the rules. There's not a lot of computation here. You just have to know the rules, but the rules can be a little confusing. So we have 3 possibilities. So let's look at the rules. I'm going to switch the screen here. And you may have to pause it just to kind of get these rules down pat. And we have to know a little vocabulary here. For the horizontal asymptote, you compare the numerator degree versus the denominator degree. Okay? And remember, the degree will always be a whole number. We have 3 possibilities. The numerator degree is higher, the denominator degree is higher, or they're the same. If the numerator degree is higher, you're not going to have a horizontal asymptote. If the denominator degree is higher, it's y equals 0. That's just it. You don't have to compute anything. Just memorize y equals 0. But if they're the same, you do have to think a little bit. It'll be y equals, and you have to figure out the ratio of the leading coefficients. And so we'll go over that with some examples. So back to this case. All right, so we got to figure out the degree. Remember, with degree, you only look at the variables. All right, so for the 5, there's technically an x to the 0 power here, which I'll write in black because you're not going to see that written. But what we don't say is, oh, the degree on top is 1 because it's 5 at first. Degree is only with variable exponents, not with number exponents. So it's 0. On the bottom, you do see a variable, but you don't see an exponent, so it's understood to be a 1. So the top degree is 0, or the numerator degree. The denominator degree is 1. Okay, so it looks like here the denominator is higher than the numerator. So going back to our rules, and it looks like my camera froze there. But if the denominator is bigger, our answer is going to be y equals 0. Try to be patient here, let our camera come back. There we go. So if the denominator degree is higher, the answer is y equals 0. You just simply memorize that. So sorry for going back and forth here, but horizontal asymptote is y equals 0. And just like it's important for vertical asymptote to have an x equals, for horizontal asymptote, you do want to have a y equals. All right, let's look at a second example. All right, so on the second example, let's say we have y equals 5x squared minus 1 divided by x squared minus 4x plus 3. This looks a little more complicated, but if you're used to solving quadratic equations, it's not a big deal. So for a vertical asymptote, I'll say VA here just for space sake. We want to set the bottom equal to 0. Remember, the top is irrelevant. For the vertical asymptote, we're doing two different things here. That's what sometimes people get confused about. They get the two mixed up, or they want to sort of blend the two. But with vertical asymptote, we don't care about the top. We don't care about degrees. We're just setting the bottom equal to 0. Now, if you remember here, you need to factor. I'll assume you're able to factor here. So x minus 3, x minus 1. That's factors of 3 that add to negative 4. You could use the quadratic formula here, but it's the long way around. And I'm just going to set each of those equal to 0. So here it looks like we're going to have two vertical asymptotes, which is fine. You can have more than that. Okay, but we have x equals 3, that's one vertical asymptote, and x equals 1, that's the other. So again, for the vertical asymptote, don't worry about the top at all. Don't worry about degrees. Just set the bottom equal to 0 and solve. When you get to the horizontal asymptote, you do have to worry about the top, and you do have to worry about the degrees. So let's go ahead and make that determination of what are our degrees here. Well, pretty simple here. You've got 2 and a 2. So the top degree, or the numerator, is 2. So I put a D here. Can't remember what I put last example. The degree, you don't have to label it. Just you can think about it. The denominator degree is also 2. So here the degrees are equal. All right, so let's look at what happens from the notes. Okay, it would be the bottom scenario. Y is equal to the ratio of leading coefficients. So let's take just a minute to figure out what that means. So what are the leading coefficients? This is more vocabulary from polynomials. The leading coefficients are just simply the numbers in front of the highest power. So 5 and 1. Okay, if you're in standard form with a higher exponents in the front, it's just the numbers in the front. So that means our horizontal asymptote is y equals 5 over 1, or a more efficient answer, y equals 5. And we didn't look at the case where the numerator degree is bigger. In that case, you just simply say none for the horizontal asymptote.